Let's take a look at some basic statistics. In this example, we have the city of Raleigh has 11,100 registered voters. There are two candidates for city council in an upcoming election, Brown and Feliz. The day before the election, a telephone poll of 550 randomly selected registered voters was conducted. 199 said they'd vote for Brown, 314 said they'd vote for Feliz, and 37 were undecided. So the question, what is the population and its size? And the follow-up questions, the next one, what is the sample and its size? Now the population is the overall population you're interested in, and the sample is a subset of that population that you inquire about or ask questions of. So in this case, the population wouldn't necessarily be all of the city of Raleigh. It's the registered voters in Raleigh. So it would be specifically the 11,100 registered voters in Raleigh. Oops. Okay, the sample. So the day before the election, a telephone poll of 550 randomly selected registered voters was conducted. So you might think that the sample size is 550, and that would be correct. And the sample would be the registered voters in Raleigh, but there's something specific about it. Specifically, anyone in Raleigh that does not have a telephone for whatever reason would not be part of the sample. So the sample is actually 550 registered voters in Raleigh that have a phone. The sampling method, we're assuming is random sampling because it does say randomly selected. Even though we've already discussed a bit that there is a possible bias. No phone. No possibility of being in the sample. No representation. That's probably the most glaring one as far as a possible bias. This is an example of a sampling bias. That is, the way that you do the sample has inherent bias in it. There's other bias that, they could be lying about it, etc. You could be asking, you could make sure to telephone poll, not so it's randomly selected. Yeah, there's lots of things that could come in, but these are the obvious ones. Give the sample statistic. Now the population parameter is how many people will vote for Brown and Feliz. The sample statistic is how many in the sample did. So the sample statistic for those who said they'd vote for Brown, in general, the proportion is the part over the whole. In this case, the part is how many said they'd vote for Brown. And here we have 199, and the whole is the 550. And we can work that out in a moment. Let's do the last little bit, and we'll pull out the calculator. Given the sample statistic, how many of the 11,100 registered voters might we expect to vote for Brown? So we're about to approximate the sample statistic. We could simplify. I don't think this reduces. So actually 199 over 550 would be an exact representation of the sample statistic. But if we go to an approximation, I guess it's time. Let's work this out. 199 divided by 550. Typically, this type of poll result, we multiply by 100, so we have a percentage, 36.18 or 36.2%, Depending on how it's rounded, they might ask you for certain rounding rules. But if they don't round at all. Go with the exact value, 199 out of 550. So this is approximately 36.2%. How many of the population would you expect to vote for Brown based on this sample statistic? Now, you might think that to do the 0.362 times the 11,100, but that's going to be an approximation. It would be better to do the exact proportion, the sample statistic, times the 11,100 and see what you get. Okay, with our calculator. And that's the exact value. There's no rounding in there, but just to make sure that there's no issues. Now, for this case, we would round down, not necessarily for the basic rounding rules, but that isn't a full person, so we couldn't say 4,017 people would vote. This is all just an approximation anyway, but I would go with 4,016 votes for Brown. Okay, I hope this helps.